Okay, airbags.
Well, he doesn't get to work.
Yes, he does.
Yeah, early bird. Yeah,
He's
early
earlier than birds. He's earlier than birds. Does he get like half a worm?
Huh?
You get like half a worm.
SRS module. Morning, Daniel. I'll draw a Humvee since we were talking about Iraq. Does that look like a Humvee?
Kind of, yeah.
I didn't mean it to, and then I
That
started
looks
drawing
like
it.
a car.
Looks like an Aztec.
So let's say there's a trace sensor here. Trace sensor, 2 wires. Both go back to the computer. Trevor, no, go sit down. We got obviously a steering wheel here. It's got a airbag module on. This probably has 4 wires to go back to the computer. 1, 2, 3, 4. It's probably got a side impact sensor on it. That's got 2 wires to go back to the computer. I don't know if it has an ascend sensor or not, but and obviously there's another on the passenger's airbag there. There's another airbag on the passenger side, and that'll have, I believe, 2 or 4 wires going back to the SRS module. And then this thing gets this is how they say data. That'll go to the ABS module, probably the PCM or PCM. It's getting data. This is serial data. It's telling how fast it's going. All that stuff is telling us. Airbag. I'm just gonna call it airbag. Make it simple. Airbag module. Tells it how fast it's going, all that stuff. Because obviously, if it's sitting still, I don't know that the airbag's will blow if it gets hit in the front. So, cars travel in this direction. What energy does a car have in it when it's in motion? Anything that's in motion, it has an energy in it. You don't got energy?
Potential energy?
Kinetic. I don't know how you spell that. Kinetic energy. So it's going that way. All of a sudden you hit a big old post. Big post just comes up and gets you. Or it could be a cow or mailbox.
Or just a regular cow's.
Goes like that. The car at that point, the kinetic energy goes into that thing there, and the car slows down. It decelerates very fast. Decelerates very fast, and you're also sitting in here like this. And if the car stops, if your kinetic energy is that way, and you decelerate really fast, what's your head want to do? Big old bobblehead. It wants to go this way, right? Obviously, airbag's got a cushion you. You smack your head on the steering wheel like they used to do in the 70s and get all messed up.
No, you don't.
So, be quiet. Kinetic energy. By the time this thing hits here, this thing has to come out before your head goes that way. I don't understand how they do it that quick, but they do. Like, that's instant. Instant. This thing makes a decision to fire that airbag and go for it. They also have seat airbags. They go nuts with this. They have a seat airbag. They have curtain airbags up here. They go back here. They have shin airbags. Some of the BWs do.
Shin airbag?
Shin airbags. I think that's what they're called. Basically, they can wrap you in a blanket.
So if one goes off, do they all go off?
Not necessarily. So if it gets a side impact from the side, or right here, from the side load sensor, from the side sensor, it might not even blow the steering wheel. If it gets a direct side hit, it might just blow the curtain, and the airbag, you know, it just puts a curtain up there for you. Curtain comes down, curtain comes out of the seat, boom. Morning, Caden. Does that make sense?
I'm kind of curious. So, like last Wednesday, there was an accident down there with the Jeep and an F-150, and
Okay.
clearly the F-150 was clearly hitting the front of the Jeep, but only the side airbags. I was looking at it, only the side airbags. The steering wheel completely intact.
It might have been a really, was it a side load?
I think it was head on the left side. So anything the steering. So what would it cause that to malfunction?
I don't know if it malfunctioned. It probably didn't malfunction.
Huh.
When did you see it? Because they normally cut out the front airbag.
Right after it happened.
It was like right after they got it.
Well, okay, let me draw how an airbag sensor works. This is literally how they work. We cut one apart. It was on a 1996 Chevy Astra we had one time. So it's a box. The old ones were a box like this. And then they had the back side, they had a magnet. And then up at the front, they had two wires coming in. And then they had two prongs like this. They were flexible, a little bit flexible, like two wires. Okay, so those are open, there's no resistance between them. They took a ball bearing, and they put a steel ball bearing right here. It was held back by that magnet. What happens when you hit a post? Decelerates, kinetic energy is still in that ball bearing. He goes, doop, shorts it out, airbag blows. That's actually how, the newer ones, I mean, they measure kinetic energy, but they have like kind of data going to them somewhat. I don't know how they work on that fan right there. They don't work exactly like this, but they still work. They get green and the connector gets corroded and they set codes. So yeah, this reports back to this guy and says, hey, I got hit. He says, okay, I'm gonna blow this circuit and I'm gonna blow this circuit, pop, pop. So whatever those circuits are, I'm gonna do the shin and I'm gonna do the steering wheel. Keep this guy safe. Let me see if I can draw an airbag. Typical airbag, like on a passenger side, a lot of times I think only has like two wires, so it has so it's got like two wires going to it. It's got dynamite in here, basically. Dynamite. Equivalent, I think, to a quarter stick of dynamite is in the airbags. I'm not making that up, I heard that somewhere. And it's got like literally a fuse that goes down here. It's got a resistor basically. It'll blow. Boom, it's about 2 ohms. 2 ohms. Don't ever measure it right on the airbag because it could blow up, but I don't think it will. But I have measured it safely, but they have about 2 ohms. If you put a 2 ohm resistor in it, it'll turn the light off. Just saying. You don't have an airbag, but. So, 2 ohms. When this thing makes a decision, it's like, you know, we hit something, this closes, boom, the ball bearing goes here, that closes, airbag decides, yes, I'm going to blow that, this is the steering wheel, it needs to be protected from going this way, it blows that. But there's 4 wires going there, so they have They have two stages. They have a small stage, comes in with a little bit of dynamite in it, and then they have another stage. Goes back out. That's a fuse. I don't know how to draw a fuse. I don't know the actual term for it. This is the big stage. Tons of dynamite. If you hit something like 20 mile an hour, you probably blow that one. Well, let's say 50 mile an hour, it's gonna blow the big one. And like, or they blow them in stages, boom, boom. They probably blow them together so they're both expelled.
I think they, yeah. I think it's they both
If you hit something at 100 mile an hour, let's just say they both go bam, blow both of them out harder, quicker. Because you need a little harder cushion at 100 miles an hour than you do at a 20 mile an hour. Because 20 mile an hour, if they made it rock hard for no reason, it hurt. So there's a lot of stuff goes into those airbags. A lot of engineering, tons of it. Griff got in a wreck in a Volkswagen one time, Volkswagen Passat, and he said it basically wrapped him up at like, bam, 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 like, it just like, it just exploded in series the way it just like, hugged him.
No, that's cute.
I know, it's cute, right?
Little hug from the wolf.
What do you think the airbag module needs to know from the ABS module? What data?
How fast it's going.
Slow speed?
Yep.
Anybody know what VSS means?
variable speed sensor.
Vehicle speed signal, vehicle speed sensor, whatever. What else?
Where it got hit.
Where it got hit? How does it know where it got hit?
There's different sensors in the code.
In the ABS? In the ABS module? This is serial data talking to the ABS module PCM. I don't even know if it needs to talk to PCM.
Oh, I thought you were talking about. Okay.
I don't really know how much
It's
information.
got different airbag sensors around the top.
Yeah, we already talked about those. Up here, side sensor, front sensor, a whole bunch of different airbags. I'll go back to the module.
You don't have much time.
What else did I need to get from the ABS module? Was you here for the ABS class? All the stuff you wrote there? No? Okay, did you watch it? No. Well, you guys were. Would they want to know if it's tilting? Would they want to know if it's yawing?
Yes,
Would they want to know where your steering wheel's at? If it's skidding?
yes.
Probably. I'm not sure what all they need to know, but probably a lot of that. So,
The rough road sensor also.
rough road sensor, yaw rate, lateral,
Yep.
acceleration.
Some even use brake, sensing a braking too, because they know you're on the brake.
Brakes. It's almost like Wesley's heard this before.
It's almost like Leslie's an 8.
Lateral, yaw, longitudinal. Is that how you say that? Longitudinal?
Longitudinal.
Acceleration?
Longitudinal.
Man, what else? I don't even know what else I would need to know.
Why not? Let's see here.
But they didn't know if you're going down a hill or not? I don't know.
That would be in with yaw in the part, possibly?
Maybe the longitudinal or the. They don't have an inclinometer, do they?
On some of like the Land Rovers, they have all that in them, and they have some weird stuff to some of them. That's more, I think, for their suspension setup that they use.
The FJ Cruiser has a. It'll tell you how many degrees up and how many degrees
Yes.
down you are.
That
They're
right
kind of
there.
cool. You guys ever see Trevor? Okay, sit down, or you're gonna have to go to my office. What else? That's probably most of it. So it's using that data. It knows all that stuff, and then it makes a decision just like boom, pops that thing out in front of your face. The right ones at the right time in the right sequence.
So is there a comparator on there?
A comparator? There are a whole bunch of comparators in there.
So it's
There's a bunch of executives. The executives probably would be from here. He's got a big head on him. He's thinking about all kinds of stuff. Big head, little body, kind of like Arnold Schwarzenegger. No, opposite way around. And then there's a whole bunch of, let's see, these little guys have, they have input. The other guy is this guy. He's got input. They're all talking that and this, you know, there's a whole bunch of information coming out through that. Do you know why they use serial data? Does anybody know why they use serial data instead of? Because they could run a wire from the longitudinal sensor. They could run a wire from the brake signal, the lateral sensor, the yaw rate sensor, the rough road sensor, and the VSS. They could run wires all that. You know why they use data?
I'm guessing as a safety precaution in case one goes wrong.
Not really.
Nope.
There's probably multiple reasons, but anybody else know why?
Aside from just less wires.
Less wires is a big part of it, right? Less weight. If they had to run a wire to every single module for every single communication signal, that car would weigh a ton, and it would cost a ton.
Yes, it would.
Because what? Cars have north of 30 modules on them, don't they? Some of them?
Newer stuff does, yes.
So if you had to run all the signals between all the wires and all the modules,
It has so much weight, oh gee, that'd be a nightmare on track and stuff.
oh my goodness, your wiring harness would be like this.
And then you also run the chance of any of those wires getting nicked anywhere. There's a bigger.
It's not like we were in the Rust Belt or anything.
No.
It's not like they think roads. Yeah, if you got something hit those, it'd be salvage car. Almost. Okay. Anybody have any questions on that stuff?
When some people modify their cars, I know some airbags that likes to go off. Is that normally just because they cut off the sensor, the crash sensor?
Like if they put an aftermarket steering wheel on?
Yeah, or stereo system, something like that. Is that because
Stereo system probably would. It depends on like what it's on, but if it's something halfway older, like mid 2000s, I don't think putting a stereo on it would cause any issues.
But is that just because it shorts it out somewhere?
They're changing something in the circuitry. So, you guys know what a clock spring is? You know why they use them and what they do? No? You know? No?
I know what they look like.
Little round thing, right? Wires out both ends. I'm just gonna draw one wire to make it simple. One wire, it goes to the center, and then it goes out, 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 out. And this, hypnotize you. And this steering wheel's up here. So you can imagine the shaft going right through the middle of there, connecting to that, and going out the other side to the rack and pinion. It goes to the wheels, it goes left and right. Okay, anyway. Why do they have to use a clock spring? Well, couldn't they just put a contactor there that would, you know, just like a
As long as you drove straight, you'd be good.
something that would just, because the horn, it beeps anywhere you go. On the old ones, they had a contactor and it just went down through and the horn beep. Why wouldn't that work there? I mean, that's kind of a pain in the butt to put a circle there. You gotta, I mean, because if you disconnect the rack and go more than like, if you don't get it back where it was, the light will come on because it'll break the circuit. It's a pain in the butt. So why do they do that? Anybody know? Hey, you know, you look like you're awake. You don't know, or you're not awake?
I don't know.
And you're not awake? Well, if they put a contactor there, is that contactor going to make connection in all positions all the time, 100%? No, it's going to have spots. It's going to get. They wear. They get carbon buildup or whatever. Or they get. You can put grease on them, but they ain't going to be great. So this is a constant. I'm going to say constant connection. And it should have basically 0 ohms, or 0.01, or 0.1 if you measure it, because your leads probably have 0.1 ohm if you measure the leads. So they should have no ohms from here to here. If you go from here to here with your ohm meter, it should be, 0.1 ohms. Make sense? Now, Leslie, how do you pick an airbag clock?
Watch free.
There's a really quick, neat way that
I probably don't know your quick beat way. I've done them different ways, you know, so.
on a wiring diagram, what's on every connector going to an airbag? You know what I'm talking about? So, yeah, connector, and I don't know if I can draw this, I'm gonna try. Obviously, it's connected, but then in this connector here, there's a, if this is the airbag on this side, so let's put the airbag up here. Boom. That's the boom. On this side, every time there is something like that, and when you plug it in, it's a shorting bar.
Shorting bar, correct.
When you plug it in, it unhooks this, because there's like plastic, or little plastic pieces that come up through here on this connector, and it opens that up, so it doesn't short it.
Correct.
And these here will go over the mod. Does anybody know why they put that shorting bar in there? Why would they put a shorting bar on, so let's say this is the connector's here and here. Why do they put a shorting bar? So if you unplug this, it comes out and goes like this and shorts those two across with a steel piece. It's gold plated.
Well, it completes the circuit with the airbags and which will let you know that there's a circuit code.
Well,
On the, you know, usually, as I've looked at it, it's like, I know that's why when you put a 2 ohm resistor across in place, you turn the light off.
well, maybe I'm wrong. I think they do that so that in case you're testing it and you put power on those wires, it doesn't blow the airbag. It's shorted across.
Oh, I never heard the airbag slide, that's true, you're right.
But here's the part of testing it that's really cool. That shorting bar is always on the side that's under the steering column. So the shorting bar, I don't know how to draw a shorting bar with one wire, but the shorting bar is always there. So if you unhook this, it goes to the thing and it shorts it out there, because you obviously have two circuits coming out here. I'm just gonna draw them there. The easiest way to test a clock spring, unhook the bottom side at the bottom of the steering column. The shorting bar goes in place, it'll short it across, and then you just measure right here with your ohm meter. And you should have 0.1 across all that and back out. You guys understand how that works?
That way.
It's really fast.
I'm like, that's fast. I've done the long way.
Other way sucks.
Yes, it does.
Morning, Griffin. Morning, Burton.
Like,
Yeah, because all you gotta do is reach under there, unplug it.
yeah,
Good, bad.
that's
Done.
really fast.
Yeah. And even if it has the dual circuit, unplug it and check one circuit and check the other circuit. They'll both short across.
Okay, I never.
So if you have 2 ohms, down at Scott's yesterday, there was a guy that had a. Hey, I got to teach him something. Finally, I knew one thing he didn't know.
I didn't know that trick. I did it the other way.
It's really fast though. Checking airbags. Burton, you know how to do that? Clock spring? They have shorting bars. You know, they have shorting bars on all the connectors on airbags. Clock spring, if you reach underneath the cowl and unhook where the wire it goes into the clock spring on the bottom side, you can just pull the airbag off, unhook it, and check your ohms right there, because it automatically shorts it across on the bottom, so it checks both circuits at once. I learned that Ford Taurus with the collapsible. Another thing I forgot the airbags have is a collapsible steering column.
Those things are frustrating when you buy that car.
So if you're right here, and you get an airbag event, this steering column, it actually fires a projectile, or fires a cylinder, and it sucks this thing down that way, like here, so it's like out of your road. It sucks the steering wheel down, blows the airbag up, so now you have more cushion. Whoosh, instead of bang! Right? Those suck, because you gotta replace the whole steering column. That Ford Taurus that comes in here that we did a lot of work to, that black one, yeah, that thing had, oh man, they have so many things on those Ford Tauruses. But yeah, that had a collapsible steering column, full steering column out, replace it, whole thing. So yeah, that was the hardest probably airbag test I ever did. Go in or out, Chris? In or out?
I'm going in.
Go sit down. Okay, go in.
Well, I'm gonna get a piece of candy.
Go. Anybody have any questions on that? Nobody? What did I miss? Have you ever seen, any of you guys ever seen these? How the old style 96 Astro airbag sensor, crash sensor works? This is literally how they work, because we saw one apart when I was little. They have a magnet back here, they have a ball bearing, they have two contacts, and it literally goes to the wires. Magnet holds it back. When it hits hard enough for the ball bearing to release, it shorts it across. That's the old ones, old big Chevy, those square Chevy ones, like in the 97s, I think they used them on. That's how they did it.
Primitive, huh?
Very, very primitive compared to what they use now. Now they can talk and all kinds of stuff, I guess. I'm not sure what all they do, but.
I'm just wondering, can you just draw one more line? It doesn't seem like there's enough going from that.
Dude, there's a lot of wires go to that stuff. I could draw more lines for Griffin, yeah.
Got everybody. There you go.
There.
Just for you, man.
You know, to be real honest, it's all connected.
Okay. I'm sorry, I ruined your guys' time.
No, I think I was doing all connected. So you like these as good as thermistors, Asa?
Well,
Thermistors still take the
I
cake,
did
don't they?
like how on the Ford Taurus they would fire a projectile so it sucks that thing in the steering wheel. That was pretty cool.
It's kind of crazy.
But it's not as good as a thermostat.
No.
No, it's close though.
Okay, we got another half hour, or yeah. What else you guys want to do? What are you gonna do next? I was gonna do AC theory, but a bunch of people ain't here for it, so. I really like AC theory, so I want to do AC theory, but
I want to hear about AC theory.
you guys all understand how a pressure cooker works.
If you boil this water here, you think you're underwater.
Hey, if you want to make fun of me, you can leave. I still know how AC works, and you won't.
You've tried to explain it to me that way.
I've never tried it on a board.
That's true.
Not much, anyways. What else besides that? Because I want to do that with Jeremy and Andrew here, because they actually could use that. What else? What'd you guys run into yesterday? What'd you guys work on? What was in the shop?
Brakes.
Brakes? Everybody know how brakes work?
Let's do calipers.
Calipers? No, I mean, I'm not drawing a caliper. I'm not drawing a caliper.
Why not?
Why not? Because you know how a caliper works.
Yeah, but there's some weird thing that might be saying how they get sucked back and blah blah blah.
Oh, the lip seal? Like the return of the piston?
I just like the brakes look good because
It does. Pretty much.
back and goes back. My guy,
But-
there was so much to them. I was like, oh.
So you got a piston, pretty big piston, and you got a housing that's probably like this. It's got a seal. That seal's probably not the ideal place, but I'd say the piston's pretty extended.
Morning, Sam. Thank you.
I see it. This goes up to the little guy pushing on the brake pedal. Morning, Sam. He's pushing on the brake pedal, pushes fluid in there. Right here, I think what you might be talking about, Griffin, is or not Griffin. Well, I haven't had enough coffee yet, have I? They have a lip seal here. I don't know if it's a lip seal, it's more of a square cut seal. And obviously this goes all the way around there, like that. And when this piston goes out, this seal kind of twists. And so it kind of follows this a little bit, and it twists in there. And when you let up, it actually brings the piston back. Am I correct on that, Wesley? Okay. Is that what you're talking about?
I don't know, maybe.
If you have a really-
You know how a caliper works, and it's like, yeah, you push the brake pedal to tell you, it all goes back. It's like, no, ASC test, you know how it works. No.
Well, he's probably right. You probably don't theoretically know how it works. But I think that's what they're talking about, though. Well, this is actually pretty good. I'm gonna keep going with this, but you understand how that would twist? It seals, the O-ring rolls, and then when you let the pressure off, it rolls back. Morning, Joel. Dang it, got it wrong.
Oh.
I am horrible with names.
Please call me Sam.
I had to learn like 5 new names yesterday. Not 5, but close. I had to learn like 4 yesterday.
Please call me. Take some job applications.
Good morning, Tyler. Tyler, there we go. Good morning, Tyler. Do what?
I said, did you take some job applications over there?
It was pretty good. It was literally like setting up my second store. It was good. Yeah, it was good. I'm like, oh yeah, just, oh shoot, you don't have that. You don't have that system. Okay, I gotta put that system in place, and then do something else. And, oh, we gotta stage parts. Well, oh shoot, you don't have the names of parts. Okay, yeah, we gotta make that too. Oh, no, there's a lot of that. Do you understand how this works? Got it? You got it dead, huh? Okay. I'm gonna show you why phenolic calipers stick. Make sense? Everybody know why a phenolic caliper sticks?
12.
Okay, I'm going to draw this on the very extreme here, but this is the piston bore. I'm not going to draw a seal, but you have to know what a seal is. This is the piston bore. No, sure. No, I'm wrong. Here. No. Can't be doing it wrong. This is the piston bore. The bore never changes. There's the piston bore, right? Okay. There's a big old caliper. It's going to push the piston out of there. Phenolic steel piston is straight. It's got a little seal here, a little seal there. Straight. As long as it's not corroded, you push it back, it's still straight. Doesn't really cause an issue as long as it's not corroded or rusted. Make sense? These are the ones that, you know what a phenolic piston looks like? Do you know? You know what it looks like? It does not steel, not aluminum, it looks like that little crap that breaks. You know what it looks like? You might. You know what?
I roughly know.
I don't have one here to show you, but it looks like,
I heard about it. Looks like pot metal.
it's not really pot metal, it looks like, it's a fiber. It looks like an intake manifold or something. It's weird. Steel doesn't warp, doesn't really change. It stays the same. Okay, so you push these back and you have a lot better luck with them not overheating. Okay, so we're going to draw what happens to a phenolic piston. Let's say this piston here, obviously it's not straight anymore because it warps. I don't know if they get, over time they just get bigger, they get moisture in them maybe, they get swelling from heat probably. They taper. So your brake pad goes out, and as the pad wears off, as we keep chewing this off, this comes out and this gap gets bigger. As this comes out, you know, if I drew it out here, it'd be like this. This gap would be plenty big. Make sense? As it goes out, the gap's fine. And also, the pad's wearing, so it keeps going out. What happens when you do a brake job?
Push it back in. Go back in.
It goes back in. Let's say it goes right to the edge, back in here, and it goes right to the edge right there. And we push it back in, and it goes all the way back in, okay. Right? You guys have all had that probably. You guys have done. What happens when you road test it? You get a good, do some braking with it. All of a sudden, the right rear wheel just locks up on that Chevy. 1500, like we've all had them do. Okay? What happened? Why was it good when you pushed it back, but not when you're driving it? Anybody know?
When you get it back past the line there, does it swell up back behind?
No. But we pushed it all the way back. So we pushed it back. This is new pad. I'm going to erase this one. So, this is with an old pad, and then we pushed it back to here. So I pushed it back to there. And it pushed back fine. Everything felt good, went all the way back. We could even move it side to side just maybe just a tiny bit. We put it together, we drive it, and it locks up. It gets tight. What happens to anything when it gets hot? Pretty much anything I know of. Okay, so when we pushed it back, what temperature was that? 80 degrees. You drive it down the road and you get on a little hard, what temperature do you get? 220? If you're hard on it. What happens to that piston when it gets hot? It gets bigger. What happens if you ain't got enough gap here when it gets bigger? Yeah, it locks up tight. What happens when it makes more heat? It expands more. What happens when it expands more and you smash on it and you force it out one more time? It stays there and it gets hotter. The more heat, the harder it sticks, the harder it sticks, the more heat, the more heat, the harder it sticks. It is a vicious cycle. That's why your brake pads turn white. And they go, then after that, you might as well change pads and rotors because you're never going to make it quiet. That's why phenolic caliper tips. I personally hate them because they break, they get big old breaks on them, they crack up, and they do all kinds of stupid stuff. I hate them.
So what did you do wrong when changing the brakes?
Really nothing, except for not replace both sides, new ones. Like that Caravan, they have the front really, they don't work very good. If there's any issues, probably change both sides. This is why, after you do a brake job, it's really good to go walk around the car, go from left front, right front, and if you can put your hand on the rotor, what I used to do, put your hand on the rotor, 1, 2, 3, ow, as long as I can do it. 1, 2, 3, ow. If it's like 1, 2, 3, and it's like, ow, hold it.
Now you got a problem.
That thing's got a problem. You can also take a rate tack and go around left side, right side, more accurate, but if you just do road tests and go out there and you're 1, 2, 3, 1, 2, 3, use different fingers because one's gonna get warm. Make sense? It's for accuracy in the barbaric way we do it. Does that make sense? But that's what I'd do. I mean, it's effective.
Why did they start using those type of brakes?
Gee, I don't know.
You don't?
I really don't. Do you guys know? Why did they start using phenolic caliper?
I was thinking probably it's cheaper to make than it was with metal.
The only thing I can think of would be cheaper.
Or pitting by chance? Because
Cheaper and lighter.
Cheaper, lighter would be one. I was thinking of pitting, you know, like old school stuff they used to pit on the
Yeah.
you know, but that was,
I don't see any good reason.
I don't either. I hate it.
Because they don't. But you know what though? What do they all make it out of? Warranty.
That's right. That's all that matters.
100K or what? 5K? 5 years?
5 years.
If they do that for the dealer, they don't give a rip. Do they? I don't think so. I'll make it out of warranty. And then they go to our shop. Yay.
Yes, sir.
We make money on them. Yay.
So by the time they wear out, is it better to just replace the whole thing or just replace the
Piston?
piston?
We don't rebuild calipers.
No.
I've only rebuilt like 2 in my life. It was on a Celica convertible, which made a difference on the brakes, and you couldn't get it. So I could get a kit for it. Redid it, but yeah, they're like $60. You just throw a new one on. Pretty much. But yeah, that makes sense why it wears. As it wears, it's getting worse and worse. It's getting a little bit larger, getting tapered, and then you push it back and she locks up. Make sense? If you ever have to work really hard, and most of you guys know this, if you ever have to work really hard to get it back, there's an issue, you gotta fix the issue, because if it goes back hard, it's gonna go out hard and stay.
Why don't you just put it in the freezer, let it shrink, and just put it back?
You could. Shrink rate.
Yeah,
This is aluminum, this is phenolic. I mean, I assume aluminum probably shrinks less. I don't know if it does or not. Aluminum actually moves a lot.
Really didn't want to buy a caliper, you didn't want to pay for the caliper, you can do that.
The biggest thing is, we didn't have a big enough freezer. No.
I see.
Okay, what else are we doing? Morning, Sam. That's the second time you're through here, right?
I had to figure out why the bed wasn't locked.
Cool. You guys bring the questions because I never think about talking about a caliper. What else you guys do? What else you guys work
See,
on?
you thought it was a stupid thing.
I did kind of, but it was awesome. So more questions.
Brake pads next.
Brake pads. We all know how a brake pad works.
What was that?
Pressure, friction. What else?
Grandpa on it was about 15,000.
What about coils? I don't know if we have enough time. to
Coils?
do this.
I can do it really quick. So I'm gonna draw what I think they work.
40,000 on it?
You have a primary,
No, that one's a new one. That's for
Coil?
That's 20,000.
and secondary. So
Okay, the
let's go. This in here, I'm gonna go primary is PCM controlled, goes in, and it's a magnet, big magnet. It doesn't have too many coils in it, it goes back out again to 12 volts typically. 8 plus, 12 volts. So 12 volts going through, and then this is a magnet. It can make a good strong magnet. It's probably got like 2 ohms, so I can do a lot of work. The PCM controls it, draws it down, it saturates, amps goes up, saturates, doing some work. All of a sudden the PCM lets go of it. Remember what I said about a coil when we were talking about the magnetic coils? When you let go of a circuit that's got doing a lot of work, what happens to the voltage? On the side you let go, it spikes. Remember I said there's a clipping resistor, and we actually seen it on the cab. Okay, so that when you let go of this, there's probably a clipping resistor in the PCM. It clips that at 60 volts or something. Morning, Jeremy. Okay, secondary side, so it makes a magnetic coil and it collapses and it does that. Second side comes out and goes to ground. This is a really small winding.
Can
No, just go back in.
Really?
Really small winding.
It's far away. Alright.
Kind of like that ABS sensor. Goes over here
The tires, I match them up, but I think they're sitting right there.
to the spark plug. Spark plug here. Goes across the end like that. There's your gap right there, so this will be grounded. Make sense? So you have 12 volts going through here, you make a magnetic coil, it does a lot of work, you let go of it, it collapses that field, and these are really close, they're probably actually wound around each other. It collapses that field, and that energy goes into this, it makes a really high, fast spark.
So every time it spikes, it's a spark.
Every time you let go of this, after saturating it, you let go of that, it sparks. I don't know exactly how that works, but I wouldn't know because I have my phone on. Nobody talks to me right now.
Oh.
Is there a good way to test that anyway, other than like we know changing the spark plug from one hole and changing the coil from one hole to the other? Like if it's got 6 coils on 6 cylinders, is there any way to actually?
This is a coil like your Subaru has on it. It's not a high-tech coil. Some of them have resistors. Some of them have drivers. They have transistors in there. If you would like to do that, go in the office. Some of them have transistors in there to do this. Some of them have 5 wires. They have a ground. They have a common power, and then they have 3 that go to the PCM. So they have 1, 2, 3. I'm not sure. I'd have to look at a diagram, but some of them have a transistor in here. I think it's kind of like that's how a transistor is. And then that goes to the coil. And that's not how it's drawn, but maybe one of these wires goes over here to run that transistor. It's basically a relay inside of there, but they all do the same thing. Every time it sparks, so this is like a 2 ohm coil, and this would be like 10 kilo ohms. Make sense? Because this, see all the more windings? This is like the bunny hair from the ABS sensors. It induces it into there and it comes out and goes to there. Make sense? That's how they work. Any question on that? How would you test it?
Yeah, can you just flip them, switch that one to the other?
Well, yeah, if you want to do it that way, but that's a good way. That's a good way to do it. Is to switch another one if you have another. But in his Subaru, he's only got 1 coil and fires 4 cylinders. How you gonna test it?
I don't know. But I love it.
You can't switch it. So, got an ohm meter. checking ohms. Okay, so we know this is supposed to be 2 ohms, right? So you go there to here. 2 ohms. Good. Okay? If you got a break in here, it's not going to be 2 ohms. It'll be out of limits or something else. Trevor, watch where you're stepping. You're stepping that stuff.
I can because I got them.
Hey. Watch where you're stepping. This here goes to ground. Another way to check the other circuit is to go to ground there and go right to the coil there. And so if we know that spec's 10K, so 10K ohms, OL. OL means trash. Obviously there's a break in here somewhere, out of limits. And then also there's another test you can do on it. So you can go from there, you can make sure that these two ain't shorted across, and you can go to there. And what would your meter read and be good on that, do you know? They shouldn't be touching inside. If they are, they're shorted. Trevor, come here. I think he's got it. Why don't you go sit down right over there? What would you expect to read here? These aren't touching. What would you expect your meter to read?
Out of limits?
Out of limits? Yeah. That particular test, but you would want to do all those different tests on that coil to know for sure if it was good. And then the real test is, if you got power and ground there going correctly, does it go bang? Because you could have, well, theoretically, I think it should work that if you have all of it right. But, so your car, Wesley, has 3 wires going to the coil because it has 2 coils. So we got power, 12 volts going into it, and then it has 2 wires that go to the PCM. Because your car has a 4-cylinder, right? It's got waste spark ignition. It fires it fires 2 cylinders at the same time on every time. One of them's on exhaust stroke, or one of them's on intake or exhaust, not at the top of exhaust, and one's on explosion stroke. It's called waste spark. One of them's always wasted. Chevy 3.1s do it. Chevy 3.5s do it. The 3.5 has a 6-coil pack, and it's got the whole ignition module underneath it. It's all in one molded assembly. But yeah, anytime you see one coil with 2 wires going out of it, it's waste spark ignition. So waste spark ignition, this here does not go to ground. So, what? No, go in there. It has another spark plug over here. And they both spark. Does that make sense? Because these are both grounded. Ground.
Yeah, that's how them Dodgers that have the coils and the wires that go to the other side, right?
Yeah. It's waste spark ignition. So if an 8-cylinder has 4 coils, it's waste spark ignition, you know it every time. Now, my airplane is a 4-cylinder and it has 4 coils and it's waste spark ignition. Make sense? But
Why did they go with the waste spark ignition?
it has 2 plugs per cylinder.
Still wasting one though?
Yeah, but if you lose one, you still fly. It's redundancy.
That makes sense.
It does use waste spark ignition, but it has 4 coils for 4 cylinders. Sounds kind of complicated.
So it's a Hemi.
Huh?
So it's a Hemi.
A Hemi? I mean, honestly, if you wanted to make a motor that was redundant in the air, you would use a Hemi. Except for the rod bearings blow up all the time. You don't want that to happen on an airplane? They do. But you could literally use a Hemi as dual, that would work great for aircraft applications. We beat this horse to death. Pretty much got it. Okay. That's about all I got for you guys.
The reason do they do those waste spark ignitions like on some of the Dodges and stuff like that?
Morning, Mike.
It's cheaper, is that why? It's cheaper
Oh,
to
it's
build, you have
cheaper.
less coils, I mean.
Less coils. I don't know exactly why they do it. They're pretty much getting away from it. That van's got a coil for every cylinder. We're going
I
COP,
think it's smart.
coil unplug.
Cheaper. There's
There's coil unplug. You know what the Chevy 5.3s are called? CNP, coil near plug.
Really?
Yes. Did you know that?
What was that?
The COPs is coil unplug. Huh? You know what CNP means?
I heard you.
Coil near plug.
Like on, that's like on the
5.3s?
5.3s, yeah. 'Cause you get the
Little tiny wire. So stupid.
It's
So
near it.
dumb. It is near it, but why do you have to say it like that? All right. Good deal.